Welcome to this video about learning how to use Git. Now in this video, I'm just going to cover how you would use Git in one of my classes, the typical way where you're just working on the project by yourself. This isn't a overall comprehensive guide. I'm also assuming that you've already set up your SSH keys that I've shown in another video, and I can link to that video in the description below. So to get started, I created a directory called Learn Git, and I changed into that directory. And you can see I opened that up in a text editor. And in there, I created a new Python file just as a little demonstration on how to use Git. This video isn't about writing Python code, but I just create one method that says hello, and I call that method. Now, before we start using Git for the very first time on a brand new machine, it's ideal to set your user name, and this will be the name that gets attached to your commits. And so you do git config global, this means on the entire machine, set your username to your name right here. So replace this with your first and last name or your full name that you want to have displayed next to your commits. And you also want to set up your email as well, and you should probably want to use the same email you use to sign up with github.com. And if you haven't created a github.com account, you probably want to do that now. And I use the same email for this and the email that you use on github.com. Now, next we need to initialize our Git repository. Now, if you're using Ruby on Rails and you created a new Rails application, the generator automatically initializes a Git repository for you. And some other code generators will do that as well. But if you're writing, say, a program in C or C++ by hand, it probably hasn't initialized. There's nothing to generate code and initialize your repository. But you can always check to see if you've initialized a repository by running git status. And of course, it's saying this is not a Git repository. So to initialize a Git repository, you do git init, and that initializes an empty repository. And if you notice, it creates this new folder in your directory called .git. Now remember, in Unix environments, Unix and Linux, a folder that starts with a period is a hidden folder, but this is where your entire Git repository and history will be stored. So now when we run git status, we can tell that we're in a Git repository, and we can tell that my hello.py file is currently not being tracked. So next we can stage our files, and staging is an area, and this allows us to choose which files will go into our next commit. Usually you want to commit everything, but maybe there's a case where you don't want one file that's been changed to be included in the commit. And that's why Git includes this staging area. Now, usually you just want to add all files, so you just do git add, and there's lots of ways you can add files. You can add them by their name individually, and you can also use wildcards and say add any file that starts with hello. And you can also just add dot period, and period means the current folder we're in, so that adds all files that have been added or changed. Now, the one thing that it doesn't add or stage to our commit are files that have been deleted. So the deleted files will still be present. So what I usually do to make sure that we have all changes added stage to be committed is I run a git add dash capital A to stage everything. So that means all files that I'm deleting will be staged, and all new files will be staged, and all modified files will be staged to be added in the next commit. And finally, we go git commit dash m, and dash m adds a message. If we forget this, Git will open up a command line text editor, allowing you to edit your own message. But you can include your message on the command line right here. And for the first one, we can just do initial commit. And you should see that the commit went through. And now if we do a git log, we'll see that commit in our history right here. So with Git, our entire commit history is stored in that hidden folder with all the changes that we make to all the files. And that is our repository. Now, right now, our repository only lives on our local machine. It's nice that we have our history and we can go back to see if we make a bunch of changes that don't work out, we can go back and see how they look before we committed. But there is no backup and we can't collaborate with other people. Those are the two reasons why we're using Git is one, to have a backup of our code, and two, to be able to collaborate with other people. To be able to do that, we need to store our repository on a server somewhere, and that's where github.com comes in. Now I'm going to create a new repository on GitHub, and I do that by clicking here and clicking New Repository. I'm giving this repository the name of Learn Git, and I'm just going to call it repo in the description to Learn Git. And I'm going to make this one public, and if you're following along, you can make yours public too. And then you just go ahead and say Create Repository. And now we're left with some instructions on how to create our repository. Now we have the option of having two different URLs. This URL is the SSH URL, and you also have the HTTPS URL that you can use, and that's where you put it in this spot right here. Now HTTPS will require you to enter your username and password each time you push your commits. SSH, if you set up your SSH keys, you won't ever have to type in your username and password, so I'm going to use my SSH URL. Now if you look at these instructions, we've already done git init, we've already done an add, and we've already made our first commit. So next we just need to add our origin, and the origin is the master copy of the repository. So on our local machine, I know a little backwards because we created this repository on our local machine, but the master copy is going to be out on the internet so that we can share it with other people, and it's going to be our backup. So that's what the origin is where the master copy is located. So you just paste that line of code in. We're going to add a remote for our origin, and I'm using the SSH URL, so make sure you're using that right URL. And then after that, we can do git push and -u. Now this part is only required the very first time you push a repository. And so git push -u, and we're going to do it to our origin, and we're going to push the master branch. And since I have my SSH keys set up, no username and password required, and we went ahead and pushed up our master branch to GitHub. And after we've done that, we can go ahead and refresh this page. And by the way, this is your repository's URL on the web up here. And we can see that we have our initial commit. So now that we have Git set up, this is our normal workflow. We start by adding a feature to our program. And so I'm going to have add another feature where this will say, print out, let's have a good day. So there's my next feature that I've added to my program. And so after we've added a feature, we've tested it, it's all working. We just need to run 3 commands to make sure that we commit and push this up to GitHub so that we have a backup. So the first command is to add all of our changes. And once again, you can decide if you want to hold a couple of change files back in this commit. You can add just some of the files, but usually you'll just do a git add -A. Next, you could do git commit -m and add the appropriate git message. And once again, the git message should complete this sentence. By applying this commit, it will, and you use a present tense verb next. So add good day to message. So just a short little message that says what you're including or what feature you added to your program. And so it should start with a present tense verb, and and then whatever you did to your program, this should not be past tense. So you go ahead and make your commit, and now once again, that's only on our local repository. We need to push this up to github.com, so you do a git push, and you might have to enter in your username and password if you're doing HTTPS, but since I have my SSH key set up, it went ahead and pushed it up. Now, before you submit an assignment for my class, I highly recommend that you go up to your repository on GitHub and make sure that you have your last commit up there. That way all your code is up on GitHub. You have a good backup and you can share all of your code with me to get full credit on your assignment. So if you're following along with this video, that's all you need to do as far as following along. The rest of this video is just going to show maybe some mistakes that you might make or some temptations to do something that will cause you problems in the future. So I'm going to show you things that you want to avoid and also some ways that you can help fix your repository if it's not working. Now the first thing I'm going to show you is we can do git remote-v. And V stands for verbose, so it's going to list out your remotes and the URLs that you're using. So if you ever want to change the remote URL that you're using, then you can say git remote, set the URL and what remote you want to set. So we're going to set our origin URL, and then here you can put in a different remote URL. So if you wanted to switch from using, say, SSH keys to using the HTTPS URL, you can paste in your HTTPS URL right here. And now if we do a git remote-v, you can see now I've switched to using the HTTPS URL. Now, GitHub has a pretty nice interface to be able to add files to your repository and add readmes, and we can even click on files and edit them up here. But you don't want to do that. You want to do everything on your local repository and push up. Just to show you what might happen if we do that, I'm going to add a file. I'm just going to add the readme, but this will happen whether I add a file or edit a file, and adding a readme. So I'm going to add this readme to my repo. And I'm going to say add readme as my commit message. So I went ahead and added that readme, and now I'm going to show you, this is actually the way Git is supposed to work. It's supposed to be distributed so lots of other people can collaborate with us. So it's not like this is wrong. This is actually might be what happens, but if you're working on a project in my class and you start editing files on GitHub, you're going to have some extra steps when you go to change your files on your local repository, which I'm going to show you now. Now let's say that I want to make a change to my code, and instead of having a good day, I want it to be a great day. And I'm going to go ahead and add and commit that. And I'm also going to show you a shortcut. So we're going to do a commit. And notice I didn't do the git add yet. I can do a lowercase a and m. So that does the git add and the message. Now I'm not sure if that adds deleted files or not. But if you just want to make a quick commit because you only changed one file, doing this all in one line is always nice. And so now we could say update hello message. And we went ahead and committed that. And now look what happens when I do a git push. Now the first thing it's going to do is ask me for my username and password because I switched to the HTTPS URL. So I want to quickly, I don't want to do that, so I'm going to quickly revert back to my SSH URL. And so by doing the git remote set origin again, I'm back using my SSH URL, so now I don't have to put in my username and password. So now I'm going to do a git push, and you can see it's rejected. Oh no. Why is it rejected? Well, that's because changes exist on my origin, and I need to pull those changes down to my local copy. So you just need to run git pull, and usually that will work just fine, but it's going to ask you for a message. Now, if you could do a git pull -m, so you could put the message on there, and in this case, it's opening up a text editor called Vim. And I don't know what text message you might have. You might be using Nano as a text editor that only works in the command line area. So you'll have to figure out how to use that. Again, if you change stuff on github.com, that's going to cause some extra steps, and these are one of the extra steps. I'm going to go ahead and leave this commit message to merge, and you just go WQ. in Vim, you press ESC to make sure you're not in edit mode, and then :WQ. Well, that's to write it and quit. And that will go ahead and make a merge commit. Now that we've done the merge commit, now we could do our git push, and it'll fix everything back up, and now we have both the README and the change that I made. In fact, if I do an ls, you see that I have that README file that I added on GitHub is now been pulled down to my local repository. Now there is a way that you can avoid making that merge commit. Let's go ahead and edit this README. Instead of saying repo to learn Git, we'll just change that to say repository to learn Git. And now we'll just say update the README. And we'll go ahead and commit our changes. So if we made a change, and we know we made a change on github.com, inside of our repository, we can just run git pull before we make any changes and commits. And it will go ahead and pull down that change that we made on GitHub. And we can see that it now says repository to learn and our files on our local machine as well. So if you know you changed something on GitHub, and if you want to avoid making the merge commit, you could just run a git pull first before you make any new commits, and that will go ahead and make our changes, and then you won't have the problem of making a merge commit. Now let's learn about something even worse that can happen than a git merge. And that's up here. I made a new commit. This used to say hello, and I just said hello class, and I just made that commit on GitHub. Now on my local machine, I'm going to say, instead of hello class, I'm going to say hello world. So now this happens a lot. Two people might be working on the same project, and one person might change one line of code to do one thing, and another person might change that same line of code to do something else. So this is going to create a conflict. So now on my local machine, I staged and committed that change. And now watch what happens when I do a git push. And it's going to say, oh, that's rejected, because up on my github.com account, I've already changed the file and made a commit. So now I'm going to run the git pull. And in this case, it's going to detect a conflict. Now, Visual Studio Code is really good about pointing out these conflicts. But as Git tries to merge those two changes together, they realize that this and this change do not work very well together. And it's actually pretty smart. Usually if two people change the same function, then Git will detect the conflict, and it will say it's up to you to change it. Now it actually puts this text in your file, and Visual Studio Code is really nice, and it gives you a couple buttons to decide which one you want. Do you want the hello world one, or do you want the hello class one? But all you need to do is decide what you want this to say, and let's say I really do want it to say hello class. We can go ahead and delete the hello world one along with those that extra text that Git put in, and we can delete this as well and make it say exactly what we want. And now again, if you're the one that gets the conflict, it's your responsibility to resolve that conflict and make sure everything is working. Now after you've resolved the conflict, you can just add your changes like normal, and we can just say resolve conflict, conflicted hello message. And now we can do our git push, and we're back to a working repository with all conflicts resolved. Now what good is Git if it doesn't do a backup? Now our backup is in the cloud, but let's say that our original machine that had our repository on it, that it either got lost or formatted, or we switched to a new machine. How do we get our code back on our machine? And with that, all we need to do is come up to here and say clone our machine. Now you can decide which URL you want to use. I'm going to use my SSH URL, and I'm just going to copy that. And then now remember that one folder, it's completely gone because it's a brand new machine. But I can do a git clone, and I can paste in that URL, and it's going to go ahead and create a new folder called Learn Git, and all of my files are there in the folder, including all of the history of all the commits that we've made so far. By the way, when you do a git log, you can just press Q to get out of it. And so now we're back up and running, and you do not have to set your origin anymore. We do not have to say git remote add origin. Its origin is already set. I'll show you that. Git remote -v. And if I spell git right, and you can see my origin is already set. So all you have to do is start adding code, then git add, git commit, git push. Now one thing here, there might be files that you're not tracking. And so if you're doing a Ruby on Rails file, your database files are not getting saved. And also there is a master key that usually is not included in your repository. So you don't want to do this just for fun. And in fact, you might want to take that master key file and make a backup of it. That way, if your machine ever gets wiped out, you can bring that master key file back. And the reason why it's not put in a source code repository is it contains potential password-like things that if they got out in the public could cause a lot of problem, like keys to be able to connect with Facebook or Twitter or other services. So that's why the master key file is not included in the Git repository. Now, how are those files ignored and not committed to your repository? Where there's a special file you can add to your folder called .gitignore. Now this is just like any other file. Git will track this file and commit this file to the repository, but it will list out files that that should not get committed into the repository. Now, one of those files are files that contain secrets like SSH keys or keys to connect to Facebook and other services. Other things are very large files like database files or log files. And another thing that you probably don't want to commit are large object files, like if you're doing a C or C++ project, you probably don't want your compiled files to do that. So the format of the Git ignore is you just list out the files that you do not want in your repository. And you can use wildcards, so any object file that you might get created using a C++, you can also just type the name of the executable. Like if, let's say you have a program that's called animal and the executable is called animal, if you want to ignore that one, then you would put that in your git ignore file or any other large file. Now you can also ignore entire folders, so we can ignore the temp folder or a log folder. And so you just list out all of the files in this one on each line that you do not want Git to track. Now, if you've already committed the file in your repository, this will not take it out. You have to do this before you make your commits. So it's good to add a git ignore file at the very beginning of your project that ignores the files that you know don't want to get committed. And if you do a git status before you commit and you see that there's a file that you don't want to get committed, go ahead and add that in your git ignore, and then you'll notice that that file will no longer be present when you run a git status.